Welcome to Sensors. Uh, Now we are going through chapter review for chapters 4 through 8. Is it 8 or 7? Anyway, yeah, 4 through 8. We're going to be hitting on everything temperature in here. And I think the book is a pretty good uh, method of reviewing this material. The book is actually improved since last version, and it's got some really good stuff in it. The first part in chapter 4, we get into how you measure temperature. What the heck is the measurement of temperature? I think most of us are very familiar with degrees Fahrenheit. That's degrees F. The idea that 32 degrees Fahrenheit is freezing and 212 degrees Fahrenheit is boiling. That's super easy to understand. Well, you probably haven't heard of Rankine. Well, Fahrenheit was one dude and Rankine was the other dude, and they had a little battle. Rankine felt that we should start the measurement of temperature at a theoretical temperature called absolute zero, so cold that there's absolutely no heat at all. There's no movement of electrons at all. And so he came up with the theory that absolute zero was 459.67 degrees Fahrenheit. So the Rankine scale is the same as the Fahrenheit scale, except it starts with zero in the Rankine scale being minus or being positive or minus 459.67. So if you see Fahrenheit minus 459.67, then that is Rankine zero. If you see Rankine, say Rankine 450, it's minus 9 degrees Fahrenheit. If you see Rankine 500, it's, uh, 500 minus 459.67, whatever that math is. So you got two different scales. They just have different 0 points. But other than that, a degree Fahrenheit is equal to a degree Rankine. They're the same distance between Fahrenheit and Rankine from degree to degree. Celsius is the European standard. You can find Celsius used all over Europe, all over Canada, and actually almost every country in the world. You're going to see Celsius used as standard. Celsius does a slightly different scale. And in Celsius, you're going to see that 0 degrees is freezing of water, and the boiling point of water is 212 degrees. So that one came a little bit later than the Fahrenheit fellow, and it was based purely on the physical properties of water. So it was basically adopted by most of the scientific community, except for the United States. The United States did try to adopt it in the 70s, but failed. We still see some measurements taken in both Celsius and Fahrenheit, but for the most part, you almost never see Celsius in the US anymore. Conversion between Celsius and Fahrenheit is a critical skill. But what I'm saying is you've got, instead of using the math they provide you, you've got access to Google. So go to Google, use their tools if you ever want to convert between Celsius and Fahrenheit. Kelvin is similar to Celsius, except that instead of 0 being when water freezes, now they move the 0, just like with Rankine, down to absolute 0. So Kelvin is the absolute scale. Almost nobody uses Kelvin anymore in the United States, except for scientific measurements. So that's an important thing. You just have to remember these 4 scales. You're good to go. In the United States, you pretty much just have to worry about Fahrenheit as the only scale that matters. But every once in a while, you run it to Celsius in the US as well. Most devices have the ability to switch between Fahrenheit and Celsius nowadays, including the temperature controllers that we're using in class. The rest of this book talks the basics of heat, how heat works. We talk a lot about heat transfer. Why is heat transfer very important from an instrument standpoint? Because instruments measure heat on different surfaces, in different baths, in different places and times and methods. And you have to understand how heat will flow into your sensor or cool will flow into your sensor so that if you understand it properly, you know how to hook up your sensor properly to whatever you're measuring the temperature of. The most common method of heat transfer for sensors is conduction. That is, when you push up a sensor right up against a steel tank, then you are conducting physically between the steel tank and your sensor. Another method of temperature measurement is convection. If I have a thermometer in open air, then the air will waft the heat to the thermometer, and just using the currents in the air, you get the heat transfer, and therefore the sensor can measure. Not as effective as conduction. And the third method is radiation, which is really no good at all unless you're using a thermometer specifically designed to receive radiant energy, like an infrared thermometer. So radiation is your third method of transferring heat.